Hey everybody, Matt Morgan here. In this lesson, we're going to talk about balancing chemical equations from Chapter 4 in OpenStax. We'll define what a chemical equation is, talk about what we need to do to balance chemical equations, and then we'll work through some examples. A chemical equation displays a chemical reaction using symbols and chemical formulas. Reactions are a lot like math equations. There's an arrow in the middle, and we treat that just like an equal sign. We have reactants on the left and products on the right of that arrow. Matter is conserved, and we'll say this a few times through this presentation. And what that means to us is we have the same numbers of the same types of atoms on both sides of that arrow. And the equations we're given aren't always given as balanced. We've got to manipulate the numbers of atoms in order to balance them. Equations sometimes include the states of matter: solid, liquid, gas, or aqueous. Matter is conserved. We talked about this earlier with Lavoisier. We balance the reactions. The method is called by inspection. I like to call it TLAR. TLAR stands for that looks about right. So let's do an example. The chemical reaction we'll talk about is what used to put the space shuttle into orbit. Hydrogen and oxygen reacting to produce water. Is this reaction balanced as written? We have 2 oxygen atoms on the left side of the arrow, but only 1 on the right. So as written, this reaction is not balanced. What we need to do is put a 2 in front of the H2O. That will balance our oxygens. Remember, we balance with coefficients, the large numbers in front. We don't put subscripts in because that will change our molecule. But what would happen if we did change H2O to H2O2? There's our original reaction. If we change the H2O to H2O2, then it will be balanced, but it's not the reaction we started with. So we cannot balance reactions by changing the subscripts. So there's our 2 in front of the H2O. So how does it look now? Oxygen atoms are balanced. We've got 2 on each side of the arrow, but now the hydrogens are not. We have 2 hydrogen atoms on the left and now 4 hydrogen atoms on the right. We're not balanced yet, but that's okay. We are getting closer. This is what we call an iterative process. We may have to do it a few times. There's our equation with the 2 in front of the H2O. Let's put a 2 in front of our H2. Now we have the same number of hydrogen atoms, 4 on the left and right, the same number of oxygen atoms, 2 on the left and right. We are balanced. We have the same number of the same type of atoms on both sides of the arrow. So what you need to do is keep balancing until you get the lowest whole number coefficients. You may see the reaction written as this. Okay, in our course, this is not correct. We do have the same number of atoms on both sides, but we will not use fractional coefficients. And you may see these in other examples and in future courses, but not for ours. Also, we want the lowest ratio of whole numbers. This version of the reaction is balanced, but it's not correct because we can divide through by 2. We can divide through by a whole number and get a lower balanced number of whole number coefficients. So let's look at another example. This next example is the combustion of ethane. Ethane is C2H6. It combines with oxygen to give us carbon dioxide and water. Note that chemical reactions will not always show the states. So we'll start by balancing the carbon atoms. We've got 2 carbons on the left, so we will put a 2 in front of our CO2. We can now balance the hydrogens by putting a 3 in front of the H2O, because right now there are 6 hydrogens on the left. If we put a 3 in front of the water, we'll now have 6 hydrogens on the right. Carbon atoms and hydrogen atoms are now both balanced. So what about the oxygen? There are 7 oxygen atoms on the right side. There are 2 on the left. Another problem is we will balance by putting a coefficient in front of the O2, but every time we add an additional O2, we're adding oxygen in pairs and multiples of 2. So how are we ever going to get 7 on the right-hand side? But here's a trick we can use. If we put 7 halves in front of the O2, we'll have 7 oxygen atoms on both sides. We can't leave the fraction there, but because our chemical equation is like a math equation, we can multiply the entire thing by 2, and that will get rid of the fraction. Multiply through by 2 gives us 2 ethanes, 7 oxygens, 4 carbon dioxides, and 6 waters. We have the same number of the same type of atoms on both sides, 4 carbons left and right, 12 hydrogens left and right, 14 oxygen atoms left and right, both sides of the arrow. All are whole number coefficients, and we have the lowest whole number ratios. There's no single number we can divide this through and still get whole numbers. So remember to build the molecules first using subscripts, then balance using coefficients. Don't try to do both at the same time. It's okay to go through multiple times until your equation is balanced. You can use fractions to help, but don't leave them in your final equation. As always, if you have questions, there's my email to contact me. Also, I have office hours Tuesday and Thursday mornings, 9 to 10 a.m. Central Time. And there's the link for that. It's also the Blackboard Collaborate. You can also make an appointment if those times don't work for you.